And today's session, we are going to talk about databases. So the idea is we are going to discuss in very brief about electronic databases, its use, and also modeling databases. And then we are going to have some session on implementing these databases. So today I'll talk about mainly data modeling aspect, which means given a problem, how do you model before you create a real database? How do you model your database problem? So that's my focus for today's session. So having said that, let me start with providing brief introduction to databases. Before we start, let's talk about data. So meaning we can simply say the data is known facts which we record on something. For example, as students, we want to keep your demographic information, your name, your address, your contact details. So let's say we want to keep track of each and every students registered for masters, for example, we want to keep. Now, when we say a database, it will be then a collection of related data. So we can have, for example, in your case, we can have students, we can have courses, we can have lecturers, and so on. So when you say a collection of related data, basically we are focusing on particular application and users. So we have a purpose. In your case, yes, we want to keep track of all our MSc students. So which the database represents some aspect of real world and also it logically organized. Now, to work with this data and databases, we need to have a software package. Simply, we need a computerized software package, right? So to maintain a computerized database, we have to use a special piece of software. Usually, we name it as database management system. In short, we say DBMS. And using typical database management system software, we can perform different operations. First of all, you should be able to define the database. When you say defining means like you have to create particular type of data and relationship. So we are going to, keep track all the records and the fields that we are going to keep. And we actually make links. And then secondly, we construct the database. We will basically create the database to store the data. Then once you store the data, then we can manipulate the database, which means we can, insert new data, we can delete existing or change existing and generating reports and so on. So these are like some of the operations which database management systems are capable of. So when you take everything together, that means your software as well as the data, when you put them together, the overall system we normally known as database systems. So if you look at typical database management system functionality, we have techniques or tools to define a database. So we have to decide on data types, we have to decide on structures, we have to decide on different constraints. Now, for example, if I want to store student details, name, usually we are going to keep track of some string data. Then date of birth, its date format, and so on. And then you have some constraints as well, of things like, for example, let's say we want to say, let's say the age should be, let's say, less than 45, for example. Or age of a person should be between 0 to 120, assume that there is a minimum and maximum range of numbers you're accepting. So likewise, you can define different constraints. Then you can construct or load So simply what it means, you are basically going to store in a secondary storage, usually in a hard disk. Then you can manipulate the database, you can search information, you can insert new information, you can change, you can get reports, everything comes under this. Right. Last thing, but not the least one is, remember when we have data, the system should supports to concurrently access the data. When you say concurrent, the term concurrent we use to say that, okay, multiple users should be able to access the data, right? And then remember, when we say multiple users, the multiple users can do various things with the database, and the data should be consistent, which means some users might insert the data at the same time, some users might change the data, some users might delete the data, but at the end of the day, the data should be valid and consistent. So that's the typical functionality of database. So if you look at a simplified database system environment, should look like this. Simply these representations like cylinders represent the databases. When we say databases, you can see we will have some metadata, that means data about data. We discuss some structuring the data, and then we have to store some data. So metadata and the stored data we can see as two different data bases. And then we have database management system software, and then there will be some users. So what you see here is how people actually interact with the database. So I told you this should be done with a piece of special software, which we call database management system software. So when we say database management system software, there are two parts. Basically, you have software to process queries and programs. And then the second one is software to access stored data. So the access could be done by some general users, or maybe those who developers or the programs, or even you can have like separate applications to develop to access the data you have stored in database. So this will overview give you some idea about how the database system environment is. Now let's look at some example database. This is called university database from the textbook that I'm actually referring. I'm actually referring for this section Nawat El-Masri and Nawat, book on database management systems. And under that, they talk about a university where you have a couple of tables. First one, what you see is about a student. We keep track of student name, student number, class, and the major. And then the second table, we have course, where we keep track of course name, course number, credit hours, and the department who actually offers the course. Third one, give me a second. Okay, sorry about that. Now, let me go back to the previous slide. We were looking at a simple example where university database, where you can see a one table contains student information. Second table, we have a course information. Then third table, we have a section, which means like courses can be taught by multiple lecturers, which means they might take different sections, right? So if you look at what we have, for example, if you take student, the what we have, we keep track of name, student number, class, and the major. So those are known as data elements. But if you go through this name, for example, if you take name, we know that the name is a string data type, which means you have a sequence of characters. And usually, sometimes you might have some limit as well. Similar to that, if you take grade report, for example, you will have a single character. So this is like, how do you define some data types? Right. So then we have another two tables, grade report, prerequisite, which will show you some examples in a database. So I hope now you got an idea about the data elements and different data types. Now, we will now switch into another concept where we talk about data models. So when we talk about the data models, so what it basically means, we are going to describe the structure of the database. So when you say structure, as we already have seen, let's say if you want to say store data about student, we want to keep track of several data elements, isn't it? We want to keep track of name. For example, if I go just quickly go back, student number, class, major. So these are like, we want to keep track. So there's a structure, right? Because we are going to keep 4 data elements. And then sometimes you need to have some constraint as well. So when you put everything together, this is known as a data model, right? So there are different data models we use when we are designing databases. And then each of these data model, we have a set of operations. So for example, these operations could specify, what are the possibilities, what operation it will support. For example, database retrievals, updates, right? How it, affects the data, right? So when we say operations, it could be some basic operation support by the data model, or even users can define their own data models. Right, now that we have understood about the data models, next, I would like to present some categories of data models. So when we say categories of data models, right, there are 3 categories. What are the 3 categories? Conceptual, which we call high level, physical, which we call low level, 3, implementation, we call representation. So these are the 3 different models. So usually when we start with the conceptual data model, with high level data model. So which means this is how many users will look at the data. So sometimes I hope you might have already learned about the entity relationship diagrams. So this is something like entity based, or if you use object based data model, so we will look at the problem as objects. Right. The second one, as I told you earlier, is called physical data model, which provides how the data is stored in the computer, which sometimes called the lower level or internal level data model. Third one, we call it implementational or representational data model, which means it's in between. Sometimes this will base on user views and also together with some storage details. So those are the three different data models. So we can create the database in three levels. And this is known as three schema architecture. So the three levels are, we call internal, conceptual, and external. Now, when you say internal schema in a database management system, usually it refers the storage structures. That means the data is stored in a database in some manner, right? And how exactly the data is stored will define using these storage structures. Then we have conceptual schema, which means the structure and constraint for the database. And finally, we can talk about external schemas. That means different user views. Right. Now let's look at a diagram which describes this. So this is what actually we discuss. We can look at different levels. So we will have external views, which we have end users, the same data set, different users can use different views. The conceptual schema is also there. Then we have an internal level which describe how the data is actually stored. And then these arrows will show you the different mapping between these two. So since this is external level and conceptual level, this is called external to conceptual mapping. And these two is this arrow will represent the conceptual and internal mapping. Right. So, but one thing you need to remember about the mapping among the schema levels are, we need to transform the request and the data. So usually you can say programs refer to external schema and map the DBMS to internal schema. So that's how usually it operates. So now, since we talk about different levels, we need to discuss database independence, or in short, we say data independence. Now, when we talk about data independence, there are two independence we discuss. The first one is known as logical data independence. The logical means that you can actually change the conceptual schema without affecting the external schemas. So if you remember what we discuss it here, right? We have different levels of this, right? So when we say you can change the external schemas without changing the conceptual, we call logical data independence. Similar to that, we can talk about physical data independence. That means you can change the internal schema without having to change the conceptual schema. Right? So one thing is you can change the conceptual schema without change the external schemas. The second one is you can change the internal schema without having to change the conceptual schema. So this is what we call database independence. So this data independence, we can say, in general, we can say, when you change something in the low level, right, what we need to change is only the mappings. right? So if the database management system fully supports the data independence idea, what you need to remember is whenever you want to change the lower level, only mapping you have to change in the high level. Therefore, if you change something about the data, it will not affect the application programs. Why? Because application form programs usually refer to external schemas. So that means you store something in the database, you can work on changing anything in the database without affecting any programs which uses the data, which is called data independence. Right. So let's look at the whole structure of DBMS. So one thing I hope you remember from previous, we normally have data and we have metadata, right? So data about data. So what you see here is different types of users, how different types of users are accessing the data. So what are the different types of users? You have a database administrator staff, which is technical, person. Or there could be casual users like managers. There could be programs, application programs, which actually uses the database. There could be parametric users. Parametric means you already have some interface where people can use your data. Right. Now, each of these different users will access data in different way. That's what we are trying to explain it here. For example, if there's a parametric users, that means general users who execute already existing functionality, we call CAN transactions. So you can see through the CAN transaction, you are going to access the database and to work with the data. So what it means basically, the queries that in CAN transactions are well studied, right? So if you well study it, then we can give it as a CAN transaction. There's no risk or minimum risk is involved in this kind. But if you look at those who are developers, usually they will have some application programs, or you might also use compilers to access the data. Then casual users such as, let's say, managers, usually they can interactively write simple query and you can get the data out. If you look at database management staff, then you can have very special set of commands, TDL statement, data definition language, which actually can be used to create databases. And then you can have privilege commands. Right. So this is what we have, component modules of database management systems and their interactions. Right. Let's look at the last part of the basic defining the database. So the databases can come from various forms. We discuss about the data models. If you consider data models, there are two types of models are available, traditional and emerging. So relational, network, and hierarchical, they are known as traditional data models. Object-oriented and object relation, usually known as emerging. Right. Then you can also base on number of users support by the system. So sometimes the system only support for one user, we call single user. Or there could be a situation where it will support multi-user systems. Third, based on number of sites over the database is distributed, which means nowadays data coming from multiple servers. For example, look at Google query. When you perform a simple Google query, you will get millions of records. These records could come from various types of computers. Then finally, we can also have a choice of whether to rely on open source or commercial. Right. Let's move to the next one. Right. This part, we are trying to understand how people actually design database. Any design of database, you have to follow some steps, which we are going to discuss it here. If we start with the database design process, usually you start with a problem. So in this part, I'm going to briefly discuss how the databases are developed, database design process. Usually you start with a problem at hand, right? So that means we want to, under the problem, we need to design the logical and physical structure for one or more databases. And then the goals of this design is to mainly to satisfy content requirement, which means your data requirement. Second one, you need to provide easy structuring. Third one, your processing requirements. When you say processing requirements, let's say, for example, in a university system, we want to know like how many course credits completed by a particular student. So it's a processing requirement. Second part of this is there should be some performance objectives as well. Now, for example, maybe you need within like couple of seconds. You don't have to wait few minutes, right? So performance objectives means you have particular requirement where you might say, okay, particular query should be executed within like 2 seconds, for example. So there should be some processing objective, performance objectives as well. And then the second one is there are different phases, like in software. I hope you will learn, development of software. You have some phases similar to that. If you look at database design, you have different, phases. The first one is known as requirement collection and analysis. So depending on the database that you want to set it up, you have to collect all the requirements that you need. Once you collect this requirement, usually kind of a description. For example, in a description, we need to say, okay, to represent the student, what information that you want to give, like the name and addresses. So we want to think about what are the requirements. So you collect all the requirements during the first phase. Once you develop the requirements, the second one is what we call the conceptual database design, which we will do. So you have a description or you have a set of requirements. So based on the requirements, you first develop what we call the conceptual database design. Then once you done that part, you have to now decide the choice of the database management system. Nowadays, there are many ways that you can store data. You can keep the data as a traditional relational database, or NoSQL database, or just as a text file. So it's up to you. So depending on your requirement, you have to decide which database management system you are going to use. Once you choose this, you have to map your conceptual model to what we call the logical model. So this is known as data model mapping, or in other words, we say logical database design. So simply, if you look at traditional our database design, conceptual design would be something like ER diagram or a class diagram or object diagram. Logical diagram means, logical database design means usually we have relations or the table structures. Third one, physical database design, the actual implementation of this. So for example, in your case, we are going to talk about MySQL. So we discuss how to create, tables in MySQL. Finally, you have to implement the database and you have to tune. So depending on your requirements, we have to optimize the use of the data in the database system. Right. Now, in the next slide, I would like to present you some structure, right? Same thing as a graphical structure. So the phases that we have discussed it here in one side, your left-hand side, you can say phase 1 to phase 6, starting from requirement collection to system implementation and tuning. So there are two things run in parallel in each of these phases. When you say phase 1, requirement collection and analysis, there should be a data requirement. Second one, it comes with the data requirement. Then there should be a processing requirement, which is, on the database applications you develop. Second one, under the conceptual database design, you have conceptual schema design. And under the database applications, you have to have transactional application design. Then you choose the database management system. Then you local schema and view design. Basically, these are DBMS independent in conceptual schema design, but view design will be dependent. And then under physical design, you have internal schema, like for example, what index to be used and so on. And finally, you have system implementation and tuning, which is SQL implementation. So under SQL, we will discuss data definition languages, storage definition language statements, or different statements we will use. Right. Okay, now that we have discussed about the requirements, let's look at into details about each of these phases. The first phase, as I told you, is about the requirement collection and analysis. Under that, we identify users and we interact with the users to gather the requirements. But this is usually time consuming, but very important. Why I am saying that if you make a mistake in this step, it's very difficult to correct at the later stage, right? So you have to be carefully work on the requirement collection. The second one, as we discussed, it's on conceptual database design, which provides you the conceptual schema, right? It is independent of any specific, database. There are two parallel activities as we have already seen: conceptual schema design and transaction and application design. Now, when we say transactions, sometimes when you make on a process, there could be a multiple operations, which we call transactions. The next one is choice of DBMS. Few factors you can think of. First of all, if you think of technical factors, you have to decide on type of database management system. There are relational models, relational databases, there are object relational databases, object databases, and so on. Then look at about the storage structures and any architectural options. Second one is economic factors. That means you should look at about the cost that you need to bear. The first one is acquisition, the database management system software, maintenance, training, operating costs. All these comes under this. Second one, you have to create the database and then you can work on the conversion. Third one, there could be some organizational factors as well. So there should be some organizational philosophy. Okay, sometimes some organizations prefer relational, some might prefer object-oriented, and even sometimes they have vendor preference based on what they have in the organization. And then when we talk about organizational factors, they have to be familiarized with the system as well. Next, availability of the vendor services. So if you're dealing with the third party, right, you have to focus on the availability as well. Okay, now that we have discussed about the choice of database management system, let me discuss briefly on logical database design. Now, when we say logical database design, simply what it means, we have to transform schema from high level to the selected database management system. And then, as a second point, you have to design external schemas. There could be two stages. The first one, system independent mapping, or we can say database management system independent mapping. And then you can tailor, meaning changing the schemas to specific database management. So adjusted schemas obtained in step 1 to conform to the specific implementation features of the data model using the selected DBMS. So what is the outcome of this? Remember, the outcome of this is a set of data definition language statements in the language you chosen in the DBMS. Usually, this could be SQL. Right. Next, we have to discuss about the physical database design. That means designing the specification for the stored database in terms of physical storage structures, record placement, and indexes. The term index, for example, is very important. That means how you may actually search data. So, some design consideration. You have to discuss or decide on a response time. That means you submit a query and how long it will take to execute is what we are going to measure here. Space utilization, storage used by the database files, and transactional throughput, average number of transactions per minute, or must be measured under the peak conditions. So the outcome of this phase is initial determination of storage structures and access path for database files. Last part, database system implementation and tuning. So during this period, we have to design the database and application programs. So you need to implement, test, and if all the tests are successful, then you deploy. Second one, database tuning, system and performance monitoring, very important, data indexing, reorganization. But remember, tuning is always a continuous process. Okay, so that's what about the database design methodology. Okay, we'll have 5 minutes break because I'm going to talk about the ER model. So let's have a small break, 5 minutes, and then. So now we have completed the requirement of database management system. We discuss the process of database implementation. And under that, we discuss about the data modeling aspect. So in this part, we are going to talk about database modeling or data modeling in short. And we mainly focus on entity relationship diagrams or ER modeling. So if you look at entity relationship model or ER model, is a high level conceptual data model where we can develop what we call the conceptual schema. So once you have a database requirements are gathered, the next step would be, creating a conceptual schema of the database. There are many such models available, but ER is one of the common extensively used technique. So an entity relationship or ER model can be used to create conceptual design of database. And the output of the ER is known as ER diagram. And how ER diagram describes the data, we can find it as entities, relationships, and attributes. So to understand the ER modeling, I'm going to use a simple example database about the university. So usually you get a small description like this, right? This database application is about a company, sorry, not university. So the first description, it says a company is organized into departments. You can see capitalization here. Each department has unique name, unique number, an employee who manages the department. We keep track of start date of the department manager. A department may have several locations. So this is about the data requirement. Let's move to the next description. Each department contains a number of projects. Each project has a unique name, unique number, and it is located at a single location. Third, we store each employee's name, social security number, which is similar to our national identity card number, address, salary, sex, and the date, birth date. Each employee works for one department, but may work on several projects. We keep track of number of hours per week that an employee currently works on each project. We also keep track of the direct supervisor of each employee. Last line. Each employee may have a number of dependents. For each dependent, we keep their name, sex, birth date, and relationship to the employee. So simply, this is a small description about the database. What we are going to discuss in this lesson is how you start with something like this to a ER diagram, which is something like this. So this diagram is known as ER schema diagram for the company database. Right. Now, before we are going to create any diagram like this, we should understand main ideas of entity relationship diagrams. So let me explain those first, and I'm going to coming back again to understand the creation of this ER diagram. Okay, first thing we need to understand what entities are, right? For example, entities mean specific objects. For example, we can say employee John Smith, department research, project productives. These are represent, entities. And when you combine all the entities together, we talk about entity types. So the employee is a entity type, right? Department is an entity type. Okay, now I'm going back to the description again. Can you identify entities from this description? You can use in the chat to answer. Okay. What we said was entities are specific objects or the things which are represented in the database. So my question is, what are the entities or entity types in the proper word for this? What are the entity types you can identify from this description? Yes. Specific objects or the things which are represented in the database. So for example, if you read the first one, we say company is organized into departments. Basically, we can say department is an entity or entity type. Similar to that, can you tell me what are the other entity types you can identify in this description? Yes, Prashantini? Prasad? Okay. If you read the second statement, project is an entity. Yes, of course. Something that we are going to describe here. Good. What about the third one? If you read the third description, any entities or entity types? Rakshana gave me an answer. What about Nilanta? Third one? Entity, any entity?
Employee.
Yes, employee. Last line? Okay, Anuttara also confirmed the same. Any entity types in the last description? Dependent, right? Yes, thanks. Both Anuttara and Rakshana gave the dependent. Of course, actually in this description, I have capitalized all the entity types. Good. So there is one thing we need to understand. Usually during data collection, we will write some description like this, our requirements. And the next step would be you look at this description, identify entities, right? Second one is attributes. Now, attributes means the properties which describes the entity. Now, for example, employee, we have can be described using different attributes like name, social security number, address, and so on. Okay, so which means if you go back to our department, the description says department has unique name and a number. So which means the attributes are name, a number, right? So those are attributes. So likewise, you should be able to identify attributes of each entity. Like similar to that, if you look at project, name and number, they are attributes. Employee, you have social security number, address, salary. So these are attributes. If you take dependent, name, sex, birth date, relationship, they are attributes. Right. The next thing is each of the attributes you have a value. For example, if you take employee, the name of the employee could be something like John Smith. The address of the employee is something like 731 Condon, Houston, Texas. So you can see each and entity you can have set of values, right? And third one, each attribute you have some data type. Now, for example, when you say a name, it's a string. When you say age, it could be some number, right? So you can have some value set, which means we call data type. Right. The next thing that we need to understand is different types of attributes. When you say type of attributes, it could be very simple. That means when you say a simple attribute, you have an atomic value. You have one value, right? But sometimes attributes could be composite, which means you have several parts. If you take address, address has several components. Similar to that, if you take name, also several components. You can have first name, middle initial, and last name, and so on. So when you have multiple, set of attributes, we call it's a composite attribute. Then attribute could be multi-value. Like if you take color of a car, early days we have single colors, but we have now multiple colors. Some cars you have, two tones, we call it, maybe black and white, right? You can have multiple value. A student can have multiple previous degrees. So we call it multi-valued attribute. Next, you can have derived attributes. For example, normally we can use date of birth, but if you compare the date of birth with today's date, the difference will give us the age. So age we derived from date of birth, right? So we call derived attribute. Next, sometimes you can combine both combined and multiple attribute. You can combine. For example, if you take previous degrees, the previous degrees you can have multiple values, but that degree you can have a college or the university that you have got the degree year, the degree name, and then there should be a field. So these are some type of attributes. So as I told you earlier, entities, when you combine, you will find entity types. And the second one is, each of these, you take one unique value, right? And then you call it a key attribute. For example, if you take a student, usually student ID is unique, which is known as a key attribute. Similar to that, national ID card number or person is a unique one. Sometimes these key attributes, unique attributes, you might not be able to find with just one attribute. We might need multiple attributes. So when you have multiple attributes, we call it normally they are composite. So when you say vehicle tag number, right, you can have number and a state. So different parts, which means it's composite. And then sometimes you can have more than one key. For example, if you take a person, right? We know national identity card number is a key attribute. Similar to that, passport number is again a key attribute, right? Then driving license number, it's a key unique, right? So what it means when you are having an entity, you can have multiple key attributes if you want, right? So this is possible with entity and relationship diagrams. Okay, now that we have discussed the basics, let's look at some notations. So in ER diagrams, entities we represent using rectangle boxes like this. The first one, which represent entity. So for example, what are the entities we had? We had department is an entity. So you can have a draw a square and we can put inside the department. Similar to that, in the description, we had project. So you can have a square, within that you can type project. Similar to that, you can have a rectangle object like this, you can put employee, right? And dependent. So similar to that, you can put it like this. So that is the notation for representing entities. Then, when you want to represent attributes, you can connect them. For example, right? So what I can do is, right? I can draw something like this. I can have employee. So I can type employee, right? So now I can draw a square, rectangle. Yes. So this is employee entity. Now we can have, yes, attributes. When I say attributes, right? So we can have, let's say name. Name is attribute. We can have name, right? When I say name, you can put it like this. And to say that the name is belongs to employee, we can draw lines. So like this, right? This is how the representation would be, right? Now, you can have several. Now, for example, in this particular case, let's say we have a social security number, which is unique. I told you it's a social security number. In short, we will say SSN, right? So it's again another attribute, right? So what we do, okay, we have social security number. We can draw a line which connects to this, okay? And not only that, you can draw a line to indicate that this is the key attribute. There could be multiple key attributes. At least in this case, we can have line like this. So we know if you take a Sri Lankan person, you can have multiple key attributes. National identity card will be unique. Passport will be unique. Driving license number will be unique. So you can have 3. In case if you use 3, you can underline, you should be able to identify all the 3. So that's how you normally represent. If attributes are directly connected like this, these are known as simple attributes. But sometimes the name, you can have 2 parts, right? You can have, for example, like first name and last name. So I can say F name. This is 1. And then we have last name. You can have 2 components like this. If that is the case, then this is known as composite, which means these ones, right? These ones is connected to this. So the name is a composite one, right? Name is a composite attribute, we call it. Then if you have derived one, then you can have dash lines. Derived ones, you can have dash lines. For example, let's say age. Age is a calculation based on, we can use date of birth to do this. So when you have a situation like this, normally you will have dashed over. Right? Age is a derived one, that's why it's an oval, but it's a dashed over. Similar to that, if you have like multi-value attribute, you have to have 2 ovals like this. So for example, this is 1, this is another one. You can have double ovals like this, which represents multi-valued attributes. Okay, so these are the representation for attributes. So I hope now you are comfortable with representing attributes. Okay, we'll move to the next part now. The next, I would like to discuss the relationships. Right. When we talk about relationships, right? Each and every entities, you have a different types of relations. We can define a relationship. A relationship means it relates 2 or more entities. Now, for example, employee can work on a projects. So what we can do is we can have a relation. So how do you put the relation? So we will have, let's say, employee. So I'm going to type employee, okay? Employee. And then we have work on project, we can say project. And the relation should be something like works on. So we can have employee and we can have project. And then we have a relation like this, works on. So now what will happen? Okay, we have project and we have works on. So this is called relationship, and you can combine the relationship with lines. So works on is a relation. Employee works for projects. Sorry, this one, it should be entity. So it my mistake, sorry. It should be, this should be rectangles. Should be like this. Okay. So you can see the works on relationship, it combines or related to two entities in this particular case. Right? Then we have to talk about the degree of relationship. What do you mean by degree? Now, for example, if you take a one particular employee, how many projects employee can work on? It should be many, right? Similar to that, if you look at a project, how many employees can work on? Again, many. So this is to say, okay, we say this is many to many relationship. So how do you define many to many? So we put down values. For example, here we can say, okay, this is many to many. I will put M and N, which denotes the many to many relation. Okay, let me ask a small question before we move to the next one. What kind of a relationship you will see between employee and a department? Employee works for department. Is it one-to-one, one-to-many, or many-to-many? This is how you should look at it. You take one item, if you connect to many, and you check one item from the other side, many, then yes, many-to-many. If it is one-to-one, then if you take one entity, should connect to exactly one from the other one. If you go back the other way around, again, it will be connect to one-to-one. So for example, if you have a principal and a school, take one principal, he can work maximum for one school. Take one school, you can have maximum one principal. So which is one-to-one. Take mother and children. For example, we can think of, yes, courses and student. You take one course, multiple students can take one student, they can take multiple courses, which is many. Now, can you tell me what kind of relationship you have if you take principal and school? Is it one-to-one or one-to-many or many-to-many? Yes. Prashantini said it's one-to-one. Exactly. So we need to understand what kind of a relationship we have, right? So that is the next thing that we need to understand. So if you take employees who works for the department, employee can work exactly for one department, but department can have many employees. So this is one to many, right? So if you take one, which connects to exactly one department, but the department can have many. So this is one to many relation. Similar to that, employees can work for projects. If you take one particular employee, can work for multiple projects. If you take a project can have multiple employees, which is many to many. And the second next thing that you need to understand is there could be like more than one relations among the entity types. So if you look at employees with the department, there are two, right? There could be like multiple relationships. So in this particular case, we have works for and managers. But one thing you remember, if you do not have a key attribute, then usually it's regarded as a weak entity type. Actually, if you look at the dependent, we are going to take it as a weak entity type. So when you have like partial key of the weak entity type, and if it is related to the identifying entity type, in our case, it's employee, what we need to do is we have to create a separate relation. Right. Okay. So we'll go back to the description. Can you identify the relationships now? Yes, I will go back to the problem. So this is the description. So what I want you to do now is spend some time and understand the relationships from the description, right? Identify the relationship based on the string given to you. So the idea is we need to now, from the description, you should be able to identify entity types that you already know now. I have put in uppercase letters. So entities are departments, projects, employee, and we have dependent. And you can identify attributes as well. Now, going through the description now, you should be able to identify relationships. For example, if you read this line from the first paragraph, an employee who manages the department, you see, an employee will manage the department. That means we talk about a relationship between the employee as well as the department. So there should be a relationship called manage, isn't it? Okay, by going through the description, can you tell me another relationship? Okay, there's a relationship between project and employee. Where does it say? Now, for example, if you read the third paragraph, it says, we keep track of the number of hours per week that an employee currently works on each project. So you can see there's a relationship between employee and project. And the relationship is works, right? What else? From the beginning, okay, manage, employee managing department, yes. Then department control projects. Then employee works for department and employee work on projects. Then supervisor of each employee. Then dependent, there's a relationship between employee and dependent. So how many then? Totally, how many relationship you can identify? Can you go through this and tell me a number? How many relations or relationship types you can identify? Is it 5 or is it 6? There should be 6, right? If you go from the beginning. Starting from that, you have managers, which is employee managers department. Then department control projects, the second one. Then employee works for department, third one. And employee works on different projects, fourth one. Some are managing the department, managers, fourth one. Then direct supervisor for each employee. There's a relationship with the same entity employee, supervision. That is fifth one. Sixth one is a dependent of. So there should be a 6, right? So this is One thing you need to figure out when you're given a description like this. Okay. I think now you are comfortable with identifying entity types as well as relationship types. Then we need to learn two things. What are the two things we need to learn? Let's go back about the relationship type. One thing is we need to understand the cardinality, which means the maximum participation. So when you say one-to-one, it means the number of entities are participating in a particular relationship. The max value is one-to-one. So if you take principals with schools or vice chancellors with universities, usually it should be one-to-one. Why we say one-to-one? Take a vice chancellor, will attach to one university, right? And university has a one vice chancellor. It's one-to-one. Then the second one is one-to-many. So when you say one-to-many, for example, department can have many employees, but employees works for only a single department. It's called one-to-many. Similar to that, employees can work on different projects. That means employee can work for many projects. And project, you can have many employees, so it will be many to many. This is called many to many relationship. So let's look at our description side. So you can see here, these are like entities. These are relations. Entities, this is relation. Then entities, controls, and we have departments. So when you say employee works on project, one employee can work for many projects. A project can have many employees. This is called maximum cardinality. Maximum number of items could be participated. The next one is total partial, last one. We call minimum cardinality. That means when you have participation, we need to identify whether it's a 0 or more. So for example, now we know that when you take employees, they can work for department. We know every employee works for a department. So it's mandatory, right? So we can have two lines. But if you have optional, for example, let's say we have a statement saying that employee can manage department. That means some employees can work as managers, but definitely we know that not all the employees are managers. So what should happen? Between employee to the manager, you have to have a single line. With managers to the department, you have double line. Okay. So when you have a mandatory constraint, you have two lines. If it is optional, then you have right? Single line, which indicates a partial or optional participation. Right. Now I think we are ready to insert or understand the ER diagram. So if you look at our ER diagram, what you can notice is we have employee. These are attributes. This is composite attribute. This is key attribute. Take department. Department name, number, both are key attributes because they can be unique. The number of locations, it's a double oval. That means it represents multi-valued attribute. Look at number of employees, it's a dash line, which is derived attribute. Some attributes are directly relevant to relationship. For example, employees works as managers. The starting date is attached here. So for example, if you look at between employee to project, so you can see if you take one employee can work for many projects. We'll take one project, you can have many employees. So the relation is many to many relation. And each and every employee works on projects. So that's why this double line projects also works on, it's also double line here. One last thing I would like to highlight here. This one, this is a relationship with the same entity type. So that means some employees are supervised by the others. So this side you can see supervisor. This side we can notice supervisee. So this is known as a recursive relationship. And you can notice that both sides you have a single line, partially. Because not all the employees are supervisors or supervisors. Right. Last part for today. Now that we have looked at, types, right? We can notice that when you have a relation with the same attribute, we are known as recursive relationship. And remember, when you have a recursive relationship, right, you have to name the two sides of it, which might have seen it here, right? So same numbers. Right. Another thing that you need to remember is relationship, you can have attributes. Now, so far we discussed, we can put attributes with the entity types. But for example, if you want to manage the starting date of a manager, start date should be connected with managers. Similar goes with the works one as well. The number of hours a particular employee works for a project is recorded with hours. Right. Then let's look at the constraints. So binary relationship, one to one, one to many to one, many to many. So we will put down these links, and then we will use participation constraint, which means you decide whether to use a single or double. Right. To conclude my today's session, let's brief on what we have covered under the entity types and key ER attributes. So let's look at the guidance. Each diagram we have to represent schemas rather than entities, and usually prefer singular names and uppercase for entity types and relationship types. But that could be changed if you want. Attributes should be capitalized like this, and role names should be like this, supervisor, and the card ratio could be put it like this. And participation constraint represented by a single line and a double line. So this is also what we want to represent. Last one, the degree of championship, right? So we have different ones. Right. So remember to represent these. I will send you some descriptions, and you can try to come up with the ER diagram for those questions. So until then, we'll stop for today. We'll meet next week.